Hello, ladies and gentlemen. Today we're going to talk about the surface area and volume of cylinders. So cylinders are like our cans of corn or our pop cans, okay? So you're going to want something to write with. You're definitely going to want a calculator and you're going to want to take really good notes, all right? So let's get started. So again, like I said, a cylinder. What is the definition of a cylinder? So cylinders are like prisms, so like we worked on, except they have circles for bases. So instead of having a rectangular base or a triangular base or a pentagonal base, okay, they're going to have circular bases. So they're kind of like their own species, okay? So when we look at this, it's kind of like I said, like a can of corn or a pop can. So they're circular bases. And if we were to lay it out flat, we'd have two bases with one big rectangle. And that's going to be like a soup can label. Okay, so that big rectangle you're seeing, that's like our soup can or just our can label. So this is telling us what's inside the can. Okay, so let's see how we might change our surface area and volume formulas. So again, like we said, a cylinder is just like a prism, so the surface area formula has to be pretty similar. So if we think back to what our surface area formula was, this was that 2 times the big B plus P times H. Now again, we just have to think about, well, what did those letters mean again? So if we take a second to think, okay, well, this meant the area of the base. This meant the perimeter of the base. And this meant the height between the bases. Okay, so if we take a second, again, a cylinder is very similar to a prism and shares all of its qualities except it has circular bases. So when we think about the area of a circular base, well, we know the formula for a circle. The area of a circular base would be pi r squared. So instead of big B, could we use pi r squared? Likewise, the perimeter of a circle, we know the perimeter of a circle is actually called the circumference, and we know the circumference is 2 pi r. So instead of using big P, let's use 2 pi r. So you can use the same equation if you would like, but we actually use a different one because we can replace the big B with pi r squared, or the big B with pi r squared, and we can replace the P with 2 pi r because every cylinder is going to have that circular base. So I would make sure you get this written down. And again, we know that R is going to stand for radius of our circle. And again, the H is standing for the height. And that's what's between the bases. So between the circles, if we want to say so. Okay, so make sure you take a second to get this jotted down and understand what it means, because as we jump forward, we're going to use it and try and find the surface area of a cylinder. The other formula then we got to talk about is the volume of a cylinder. And again, just like a prism, we could use the big B times H, where the big B stands for the area of the base and the H stands for the height. But like I said, a cylinder, we always know that a cylinder is going to have a circular base. So instead of using just big B, can we use the area formula for a circle, which is pi r squared. So again, instead of using this first formula, which you still can use if you like, for cylinders, we use this formula because we know that every base of our cylinder is going to be a circle. And again, just jotting down what all the unknown variables mean. So the r is going to be our radius. And again, the h is going to be our height, which is between the bases. Okay, so again, just like our prisms, we are using the same formulas, but instead of using a big B, we're using the formula we have for circles because we know that all cylinders are going to have circular bases. All right, so here we go, and we have one shape again, and we're going to find both the surface area and the volume of both. So if again we think about the surface area formula, we have surface area equals, okay, we got 2, it could be big B, but again it's pi r squared because we're talking about cylinders, plus 2 pi r, which is, this would be our perimeter, our circumference, h. And again, the reason we use this formula is because there's only 2 unknown variables here. So if there's only 2 unknown variables, I just have to figure out what those variables are in my picture and plug them in. So if I were to plug them in, I'd get 2 pi. Now our r, our radius, it looks like the radius is going to be 3. And I'm going to have that squared, plus 2 pi, r again is 3, and the h, which is between our two bases, so connecting the circles. Now it's not on the outside this time, it's connecting the center of our circles. Would that still be the height? It is still the height because, again, it's connecting the centers of the circles. As long as it's making that 90-degree angles, connecting the circles, you will be good. Okay, so the h is going to be 4 feet. Okay, so now what we have is we have an equation that we can type directly into our calculator. So again, when we type this into our calculator, again, we're going to want to type in 2, use your pi button, left parenthesis 3, right parenthesis, squared, plus 2, use your pi button, left parenthesis 3, right parenthesis, left parenthesis 4, right parenthesis, hit enter. And again, if you type that in one fell swoop, you should get back one answer, which would be a surface area of 131.95 feet. And again, with surface area, we're using squared. So that was with me just plugging in with what I knew or what I was given in my shape, and then using my calculator to my advantage and getting back one number, rounding to 2 decimal places. So let's try volume. Again, the volume formula, we could use big B, but I'm going to use pi r squared, and then h, because again, that big B, that base, is always going to be a circle. So if I were just to plug in then for what I know, again, our radius is going to be 3, so 3 squared, and our h is going to be 4. So again, I'm going to use my calculator to my advantage. I'm going to hit the pi button. Then I'm going to do left parenthesis 3, right parenthesis, squared, left parenthesis 4, right parenthesis, hit enter, and the volume I'm going to get back is 113.097, which rounds that up to 10. And again, this is going to be feet cubed because we're talking about volume. Now you might be thinking, okay, well, how can I have less volume than I have surface area? Remember, surface area is the entire outside, so it might take more material to create the object that's holding the fluid. So you might have to use more resources to build the actual can than you might actually be storing inside of it. So it is okay to get a surface area that is larger than your volume. It might not always happen, but there are instances it does. So again, if you're getting these two answers in your calculator, you would be golden. All right, example 2. Now this time it's a little bit different because it wants us to find the missing measurement. So it looks like in this picture, our missing measurement is going to be the height of our cylinder. What's given to us is then an S, and now so it doesn't look like what we normally look like, but it's giving us the surface area. So we're going to have to use the surface area formula with the total amount of surface area and what we're given to help us solve for that missing. So let's start with a formula. So the surface area formula that we have for cylinders is 2 pi r squared plus 2 pi r h. So from here, all I'm going to do is I'm going to take everything I know from this picture on the left and what's given to me and plug in for those. So I know that the SA, or the surface area, is 1097. So I'm going to put 1097 in for the surface area. 2 pi stays as is. We know that the radius then is going to be 8.2 because that's what it shows us, 8.2 squared plus 2 pi. Again, the radius is 8.2, and the height, this little h back here, is what we're trying to find, so I'm going to leave that as an x. When I type all that stuff in, or I plug all that stuff in, it looks like the x is all that I'm trying to find. So we're going to use reverse PEMDAS to help us solve. Well, before we can do that, let's figure out what these are as decimals. So 1097 is going to stay the same. Now I'm going to type in 2, use my pi button, left parenthesis, 8.2, right parenthesis, and square, and I'm going to hit enter. I'm just going to type in that first part and get a decimal. So then the decimal I get there is 422.48. And again, I'm taking it step by step here to make it a little bit easier on myself. Now I'm going to figure out what that number is in front of the x. So I'm going to take 2, use my pi button, then I'm typing left parenthesis, 8.2, right parenthesis, and that gives me back the number 51.52. And again, I still got that x back here. So it looks now like I just have an algebraic expression or equation that now I need to solve for. So I'm going to subtract 422.48 from both sides. And when I take 1097 minus 422.48, I get back the number 674.52. So that equals our 51.52x. Now to get x alone, I divide both sides by 51.52. 51.52, and when I type that into my calculator, you should get back an answer that x is going to equal 13.09. And again, what were we trying to find? We were trying to find the height, so let's give it a good label. Height is one-dimensional, so all I'm going to label this is with meters. So again, that was a little bit fast, and I know I'm probably better at typing into my calculator. I've had a little bit more experience. So take the time, make sure that you can get it typed into your calculator and you know how to use your calculator as we move forward, because that's going to be super important. Okay, so I want to thank you for taking good notes, and I will see you when I see you.